Good morning, good afternoon, or good evening, everyone. Welcome at another episode of AI Talks Live.
Hey, my name's Akansha Malik and I'm from Melbourne.
Exit Sami in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, I'm Tess. I come from
I'm
Spain.
Prasant from California.
大家好，我是卢建辉。
I'm Arfan Kasim from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California. Hi, Mehdi Ali Daoud from Ghana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daronya'dan.
Hi. Hi.
Hi.
Hi, everyone, and happy to have you all back at another episode of AI Talks, where we'll discuss specific topics, of course, about AI. Could be research material, could be practical stuff, it could be for beginners, it could be for experts. Everyone is welcome, and we're all glad to have you on board today. Just as every week, we have another guest speaker, and today we're having Mesut. Hi, Mesut. Thanks for joining us.
Hi, everyone. Fine, thank you. And you?
I'm fine. I'm happy to be hosting AI Talks again. Last week was not possible for me, but of course we always have some go-goes. Mesut, can you introduce yourself? Who are you? What do you do in your daily life? Where are you based?
Yeah, sure. First of all, thanks for having me here, and I'm very glad to be here. And as you already know, my name is Mesut. And I'm working as a QA engineer. I have total 12 years experience, and currently I'm working for Siemens. I'm from Turkey and I'm located in Istanbul. So I'm working in the Siemens Istanbul office. My main responsibility is the test automation responsibilities, tasks. But of course, we are trying some tasks with machine learning assistance. So this is what I do roughly, the automation of end-to-end test cases and deploy them, integrate them into CI/CD pipelines.
Cool. Sounds very interesting, Mesut. I think many people would like to know more about how to combine testing software with AI. There's a lot of parts that you need to do manually at the end. So if you would be able to create new tests on an automatic way that can improve our software, hey, who's not up to that? So with that, Mesut, I'm just going to share your screen with the public.
Okay.
I'll give the platform to you. All the best.
Yeah. Okay. Thank you very much. And as an introduction, as you told, it's a very interesting topic actually, because the adaptation of machine learning into software testing practices, because normally sometimes at the first glance it seems irrelevant. I mean, what is the relevance between software testing and machine learning? But in the session, we will talk about this relationship, and we will discuss what we can do with the help of machine learning in software testing. So, okay, I will not introduce myself again, but on the slides, you can see some contact information for me. So please do not hesitate to reach out to me. And if you have some questions, please do not ask them and somehow contact me.
If you have any questions during the session, you can always ask on the YouTube chat or Facebook chat or wherever you are watching on streaming, so that we can make it interactive.
Yeah. Sami, please interrupt me because I will not be able to check the both screens. But if you have any questions from the YouTube, you can interrupt me and we can check that questions. So in the session, we are going to talk about, as I told, some adaptations of machine learning into software testing. So this is the brief agenda. First of all, we will talk about some basics of machine learning and the background. I mean, maybe most of the people in this session who are listening to us are already familiar with the background, but we will talk a little bit about the software testing perspective. I mean, what does a learning mean from testing perspective? And is it really important to understand or to learn the dynamics of the system from testing perspective? Then we will see what we can do in different stages of software testing with AI assistance or machine learning assistance, and I will try to do that in a systematical manner. I mean, in a classical software testing lifecycle, we have some phases, right? Starting from the analysis of requirements, and then we will define test cases, implement them, execute them, and at the end of the life cycle, we will continue our life with the maintenance of the test cases and analysis of the execution results. And finally, after all this, I will share a case study in which I try to classify the bugs. I mean, we have some bugs in our issue track system, which is Jira in our project. And I try to classify the bugs according to their severity levels in the study. I will share some results, and we can check how it looks like. This is the rough workflow of the talk. So let's start with the introduction section. First of all, it would be better to start with why are we talking on this, right? Because I mean, why are we trying to search for some adaptations of machine learning into software testing? Because normally we have some challenges, right? Because as all the other software development lifecycle, in software testing as well, we have some challenges. Nowadays, we have some challenges in the software market. I mean, nowadays in the software market, there's a great rivalry. Everyone is trying to be the first in the market. So everyone is in a rush, and they are trying to be the first in the market, and they are adapting all the technologies in the products. We have lots of integrations to other platforms, and we are trying to reduce the cost, and we have a limited time to ensure all the functionalities. Since they are adapting all the different technologies and latest technologies, we have a complicated context to be verified, and we have a limited time. Because I remember sometimes in our deployments, I have a testing window for only 1 hour or less, maybe. So it's a very limited time. And we are living in an agile environment, so we have encountered lots of frequent updates. I'm trying to develop a test case, and before I finish it, I am told that, okay, the feature is updated. Now you should ensure not that one, but instead this new functionality. So there are lots of frequent changes. So these are the challenges. So I have a limited time. I have lots of things to do. And we have some, as human beings, we have some weaknesses across these challenges. So this is why we are trying to adapt some different platforms or technologies, and we are searching for some help from someone. So in this point, at this moment, machine learning is a powerful candidate to help testers or to help human beings to reduce some manual efforts or to succeed some achievements in a more consistent way. Because sometimes people cannot act very consistently, because it is dealing with big data is not that easy. When we are dealing with very big data, sometimes we are not able to be very accurate and very consistent. So we will see lots of alternatives in which machines act more consistently than the human beings. So to deal with these kind of challenges, robots and machines are good candidates to help us. So now let's discuss if they can really help. We all know that machines are programmed already by human beings, so they have already some limitations and some capacities, limited capacities. But of course, there are some definite advantages as well. For example, they don't get tired, right? Because when the manual testers or the human testers work for a whole day, after the long working day, maybe they get tired, and it's very likely to miss or to overlook some bugs, some vulnerabilities on the product. Because you are already tired, you immediately go to home. It's enough already. It's a long day, so you are already mentally tired and you are not focused anymore. But for the machines, it is not the case. So they are performing at the same level all the time, or they are performing almost at the same level almost all the time. So it is one of the advantages. And another advantage is we discussed that we have some resource problems because we have some limited time and we have too much things to do. So when we think to add some additional resource in terms of people or in terms of the headcount, it is not that easy because for a human being, you need some adaptation time, right? Because you will first teach all the dynamics of the system to the newcomer colleague. Then he will learn all the things in the system in the project, and then he will start to perform. But for a machine, you can immediately add an additional resource. If you need some more resource, then just create another virtual machine, right? It's it. So you can immediately add some resources. And finally, they do not get forget, or they do not get forget something. I mean, if you put an information into a machine or into a virtual platform, it is not deleted unless you delete it. So they do not forget, but for the human beings, sometimes it is very likely to forget something to do or forget what to do or how to do. So it is one kind of problem that we face. And in most of the platforms, we already see that the machines started to overperform or they started to beat human beings. For example, in Go game, it is one of the most difficult games in the world. The robots start to beat the champions of the game. So in some situations, machines are really performing better than human beings. And again, in the examples, we will see some different illustrations. And we already see that most of the applications use machine learning already in their platforms. So in this table, I tried to summarize some applications or some platforms, some products, and these are mostly related to software testing applications or software testing purposes. But apart from these, actually we see them in our daily lives, right? For example, today I replied to one of my emails, and when I start to type the email, after I type some letters, I see that the rest of the sentence is automatically completed. So it is something that makes life easier for us. I mean, I don't have to bother myself to complete manually because the machine does it instead of doing it manually. And I'm happy with it because it's really very consistent. And I see that the rest of the sentence is really what I intend to do. So we see that they are performing in a very good condition. And sometimes in our daily life, we see that another example, my smartphone warns me when I'm late for work. It warns me that, okay, you should go out in 5 minutes, otherwise you will be late for the work. How does it know that? Because it knows where I live. It knows the traffic level in where I live. It knows the distance between my workplace and my home. It knows everything because it learns everything about me. Sometimes there are some humors around. They say that the machine is knowing me better than my wife, because really it tracks your data and it learns everything about you. It learns what you do in some certain time, what you read. It recommends some similar articles according to your readings. So the key point here is the learning. I mean, it tracks your past experiences and it learns something. And in the upcoming examples, it according to the past experiences and learnings, then it gives some outcomes or it gives some feature actions according to them. So since we are heavily talking about the learning, what learning means, and especially for the software testing perspective, why is that very important? Because learning is something different than memorizing something or being explicitly programmed. Alan Turing was one of the guys in the industry or in the academy who was asking this kind of questions: or can machines really learn, or can machines think about something? In 1950s, he had some articles, and he had this bravery to ask these kind of questions. So it is really learning is as a terminology is of great importance. And let's illustrate this over two sample scenarios. In one of the scenarios, let's imagine one child is trying to touch to a hot object. For example, let's imagine a cup of coffee, right? After, at first, he doesn't know that he can feel some pain in his fingers if he touches that. But after that, after he feels the pain in his fingers and in his hand, in the next trial, he will not touch the hot object, right? Because he had this experience. Even if it is not a hot cup of coffee, but it is a cup of tea, maybe it is something else. But he did not memorize. He knows how it works. He knows the mentality between that or underlying that. So he did not memorize only the cup of coffee, but even he sees a cup of tea, he will not touch to that hot object. And on the slide, on the image at the bottom, I think you can all imagine what it is, right? It's a chair, or it is a special form of a couch or something. But in short, it is something that we can sit on, right? Because it doesn't seem as a traditional chair with 4 legs. But still we can guess for what it works, right? Because we know the mentality underlying that. So the key point is really the learning principles and how the system works. So in software testing, it is a very important concept because first of all, before we start our testing activities, the first thing we do is to completely learn how the system works and perform an exploratory testing. The first thing is to know system in full manners and then start to our activities. And these learning principles are really very similar to our biological learning principles. I mean, all the algorithms are really inspired of some biological learning. For example, when we see a cat in front of us, how we process it, okay, first the light goes inside from our eyes, and then the processing starts. And there's a gradual processing in this process. For example, first of all, we process the outermost frame. Maybe the size, firstly. So the first thing we understand is the size of the object. So first of all, I can decide it is maybe a cat, a dog, something, but it is not a lion because it is not that big. The first thing, and at this moment, we can start to talk about features. So the first feature that I'm processing is the size. So the first thing I can decide is it is not a line because it's not that big. And I can continue to my processing with the other features one by one. And at the end of this gradual processing, I decide that, or I predict that perhaps and most probably it's a cat. So in all the or most of the neural network algorithms and some other algorithms, we can see such kind of processing, such kind of gradual processings. And we can regard that they are really inspired of our biological learnings. And quickly, let's remember the background of the working principles of machine learning algorithms. At this moment, data is very important, right? Because if we do not have sufficient data, perhaps we will not be able to teach to machines. I mean, again, very similar to human beings. If I'm a tester and you come to me to ask to test your system, my response would be, okay, I can test your system, but first of all, tell me in what conditions I expect, or your product is supposed to act like what? According to what inputs, which outputs should I see, or which actions should I see across my interactions on your system? I want to, or I have to know this, because otherwise I will not have expected results, because I will click on some buttons on your system, and if I do not know what to see, then how can I test it, right? So I should know first, and I should learn how it works, or how it should work. So the data is very important in this manner, and data and information is very important. And if I'm provided with sufficient data and sufficient information, then I will be able to know how your system works, and I will be able to test your system, because I will have some different use cases and test cases. Having use cases means having test cases as well. So, and I will have the relevant, regarding expected results. Because in my past experiences, I navigate to some pages on your system, and I see when I click a button on the page, I see where it navigates to. I see the next page. So I know what I should be seeing in the next round. So this is the basics of the learning algorithm. First of all, we feed the data to the machine or to the model. And according to these learnings or these experiences, a model is constructed to simulate the system. And according to this model, the incoming or the next, the further samples can be predicted accordingly. And at the end, if we, when we evaluate the system, if we are concerned with the results, then we can proceed with the current algorithm. Or if we are not concerned with the results, we can update our model to reach a better results. And according to our problem, of course, we can use some relevant algorithms. It can be a supervised learning problem, or it can be an unsupervised learning problem. For example, at the end, I will show you two case studies. One of them is the supervised learning problem. One of them is a supervised learning problem, in which I try to classify the bugs. Because it's a supervised problem, because we have some labels on the bug. We have some severity labels. On some of the bugs, it is labeled with high severity label, but for others, they are labeled with low severity bugs or low severity labels. And in the other case study, we do not have any labels, but we only try to make some clusters on the bugs. Because I will talk about the purpose on that study. Why are we trying to make some clusters on the bug? We will talk about it at the end. But as I thought, according to your problem, we can embrace some supervised learning solutions or unsupervised learning solutions as well. So after this background and the quick reminders, let's see what we can do on software testing activities with AI assistance. I mean, what's the relevance between artificial intelligence, machine learning algorithms, and software testing activities? As I told, I will try to do this or investigate this in a systematical manner with step by step. And this depicts a classical life cycle of a software testing stages. We start with software test case definitions. Then we continue with the implementation of them. And finally, we continue with the maintenance. As I told, for the definition of test cases, we start to analyze the requirements. And then we design our test cases. But the key point here is we make a traceability between them, right? We map the test cases to the requirements, because we design our test cases across the requirements. If that is not a requirement, or that is not a feature which is described, then I won't have any relevant test case. So the key point is the mapping between those two, the traceability between those two, and a similar relationship between those two again exists in the next stages. I mean, again, a relationship exists between the test cases and the test code. I mean, for example, perhaps most of we have some IDs in our test codes, right? For example, I develop a test class, and in this test class, I have some different or separate test methods, and in each method, I'm expressing across which test case I'm writing that method. I'm filling an ID in the code with an annotation, and I'm expressing across which test case I'm developing that. So which test case I'm covering with that method. So there is, again, a mapping between those two. And finally, if we are creating some bugs, of course, we are mapping these bugs to the test cases or use cases, right? So all I'm trying to say is we will make use of these relationship because we have some input-output relationship between those two. And the input-output relationship really will enable us to perform something automatically because we are or we will investigate the requirements, then we will be able to automatically generate some test cases. Because from the past experiences, we had some input-output relationship. If we have a requirement regarding, for example, a data upload feature, just as an example, then we in the past samples that we saw that, okay, for the data upload, we have some positive scenarios which tries to upload data in some different data types, integer, string, or some other types. We already saw in the past experiences. So for an upcoming feature on a different service, if we have an upload feature, then we will be able to automatically generate some relevant test cases as well. So we will discuss all this in detail soon. So let's start with discussing them one by one. The first thing is, as I told in the previous slide, is the test case definition. When we start a software testing project, the first thing is to define test cases. Then we will execute them, all of them, and we will check the results of them. So the first thing is test case generation. As we told in the learning slides, at this moment, learning of the system is very important. So if it's an API, then I can learn how the APIs of or endpoints of the product works. I mean, when I perform a query or a successful query, I can parse the results or parse the response code, right? And I can learn that when I'm sending a successful query, then I'm getting, or I should get, some 200 response, which is the successful response. Or from the past trials, I can learn that if I send an unauthorized query, I can get a 400 response, or not 400, but 401 maybe, or 403, which is the forbidden response code or unauthorized response code. I can learn all this and the working principles of the APIs. Or if my product is mostly consisting of UIs or front-end interfaces instead of APIs, then again, I can click on the buttons, I can navigate through the pages, and I can learn through which icons I can I will navigate to. Let's see some more examples, and I hope it will be more clear right now. For example, this one is an API example. From this is an API for a library in which there are some books are stored. And from this example, I can see that, or I can learn that, okay, in this library with a get query, I can get all the books, and in each book entity, I will have the ISBN information of the relevant book, and the price of the book, and the publishment year of the book, right? And I can see that the data types of those fields. I mean, in a year, we will have some integer values, or in the price field, we will have some double values. And what I can do in the next round is, I can inject some values to generate some additional test cases. For example, if I intend to add some positive test case, then I can inject correct data formats into these fields. Or if I intend to generate a negative test case, I can inject malformatted values in these fields. I mean, if I put a string value into year, for example, I wrote Mesut into a year field of a book, right? Then what will I have? Most probably, I will have some wrong response codes. Maybe it will be 400 or something. So see, we already generated the test case according to our past experiences, because we already know what should be the responses be like, or we already know what kind of queries should be handled by the service or by the product. And for an API, for an UI, sorry, mostly we are dealing with some icons or some buttons on the page, right? And I will illustrate this again with a real life scenario. For example, today I went to an online shopping cart and I ordered something for me. I intend to buy online a bag for me. So I got a shopping site, and I was really successfully able to buy the item that I want to. And that was the first time I used this site. And no one taught me how the site works, and no one taught me how I should buy an item. And okay, then how do I know how to buy an item? Because I used lots of different sites before, in advance, before this one. And I know what a basket icon means, right? Because I know it from different platforms, and most of the platforms work very similarly. So from my past experiences, when I see a basket icon or image on the page, I already know that if I buy an item, it will go into that basket, into that shopping cart. So it works similarly for the machines. It processes all the images and all the icons on different platforms. And for an upcoming sample, in a totally new site, if it detects an item which looks very similar to one of those different items or icons, then it can predict what it is, or it can assume what it is. So this is mostly related to visual processing, because in the test implementation steps, in the next slides, we will see why it is too important to implement visual recognition, especially for the front-end automation. And okay, after we design our test cases or develop our test cases, the next thing is to, after we design them, the next thing is to develop them, right? To develop the code, to be able to adapt them in our pipelines or integrate them in our CI/CD pipelines, because perhaps we will have some nightly runs which automatically runs the developed code. So in this manner, developing test code is an important part of the end-to-end lifecycle, and sometimes it really requires some time and manual effort to complete this. Because after I develop some code, I will send it to one of my colleagues in the team, and he will review it. And if I need some refactoring, he will send it back to me. I will again refactor my code, send it again. It can be very cumbersome in this manner. So when we try to reduce this waste of time and waste of manual effort, we can pull machine learning into the play, right? How we can do that? For example, let's go over an example. On the slide, you can see an input-output pair. And for the coming input, we suppose, or we expect the relevant output, which is expressed in the slide. So for a human being, it is not very straightforward to see the relationship between those two. But for a machine, it can immediately understand what is the relationship. It can detect the probable processes or operations to reach to the output. For example, for this example, all the entries in the input are multiplied with 4, and all the positive samples are filtered out. As you see, for example, -17 is the first entity in the input, right? And it is multiplied with 4, and it is -68. And we can see it in the output at the last. So at the end, we can see that multiplication with 4 is applied onto the input, and ordering or sorting operation is applied, and a filter out on the positive values are applied. So these operations are predicted by the machine, and after those are predicted, the needed operations are found. Then application of the relevant code is very easy, because we have some sample repositories for those kind of operations, and they can be simply adapted into the code. And this is what I'm talking about for in the front-end operation. I think most of the testers know this problem. This is a pain in the ass for us, because when you are developing some UI test code, the next day, most probably your test can be broken because you see that it was running yesterday, but when you analyze the test failure, then you notice that the ID of the element has already changed or has been updated by a developer. Because you try to find the elements or the elements by their selectors. I mean, maybe by their ID or maybe by their expat, and it is a very difficult task. And even if you find them, the next day they can all change. So instead of doing like this, we can all try to do that by visually. And this is a sample code which is taken from test.ai library. It's an open source library. You can go and check it out. And in most of my slides, I'm showing you some examples from some commercial platforms and some open source libraries. So this can be regarded as an literature survey as well. So in this code, we can see that the elements are found by their visual representations instead of traditional selectors. And after we implement our test cases...
Mesut, I have an interesting question from Abhishek. He's asking, to train a machine learning model to test APIs, can we use service documents that are generated by, for example, Swagger or MuleSoft as requirements?
Yeah, exactly. Yeah, this is a good question, because in the Swagger documentation or some other documentations, as I told, the description of the API is expressed or is told to the customers. In the documentation, you can see that what type of data should exist in different fields of the API or the structure of the data. So you can learn from the documentation as well. Yeah, that's right. And one way is to go over the past queries. For example, if you are performing your test cases over Postman, most probably you have some sample queries and responses. You can go over them, or as an alternative, you can go over the documentation as well. So yeah, that's right.
Cool. Thank you, Abhishek, for your question.
Yeah, thank you for that. And I will go a little faster because we have a limited time. And yeah, the execution is the next one. After we develop our test cases, the next thing we will do is to execute them, right? And related to execution, what can we do with the help of machine learning? Let's think about it. For example, I can collect some data, right? For example, I execute my first execution. I run my first execution. Then I can collect some data. For example, maybe I can pull the execution duration from the execution. And in the second run, again, I can track this information. And after a while, I can learn in which circumstances, how long the duration will be. So how we can utilize this information? For example, let's say that we learned that for an upload query, the execution duration is 10 seconds, okay? And if I have 20 seconds in one of the executions, then machine can warn me, okay, there's something wrong here, because normally I learned that the execution duration is supposed to be around 10 seconds, but in this one, it is 20 seconds. So please go and check it. So it is, just a collection of useful and valuable information. And according to this information, according to the learnings, the past experiences, then it takes a action item. And I can get advantage of this because instead of analyzing all the executions manually, I can only concentrate on the one which machines forwards to me. And for the maintenance tasks, one of the operations that we perform is refactoring of the code. And it's a really very important part of the overall life cycle, because it relates to the quality of the code. And the quality of the code is very important because we have some fragile codes in our pipelines, and we have some vulnerabilities in the code, and they stem to, or they result in some test signals in our code. So it is very important to reduce these refactoring efforts and the vulnerabilities in our code. And again, with the help of machines, we can do that automatically, because we can again teach to machines what an anti-pattern is or what a best practice is. I mean, for example, let's imagine one example. Having some magical numbers in the code is an anti-pattern, right? It is not a best practice because we have some embedded numbers in the code and we don't know what it is injected for. So if I teach this rule to the machine, then machine will be aware of this rule. It will learn it. And in the next examples, if it see such a similar scenario, then it will learn that, okay, in the past you taught me this is not a best practice, but in this example, I see some magical numbers in the code. So it can again automatically detect the vulnerabilities or the anti-patterns in the code, and we can perform the relevant refactoring on the code. And self-healing for the broken tests is very important because, again, we need some manual effort to do that. Because normally, without some machine learning assistance, normally what I would do is try to understand the reason of the failure, because I will go and check all the logs coming from the executions. I will investigate all the logs, and sometimes it's really very difficult because we have a huge amount of logs. And I will try to understand from at which point the test failed, the reason of the broken tests, and I will try to figure out the relevant action item to fix that. But a machine can detect it immediately in a very fast manner and in a very consistent manner, because it can check the last execution which was successfully performed and the execution in which it failed, and it can check all the differences between those two. And it can warn me to perform the fix. I mean, if the reason is the change of an ID of an element, then if I accept the proposal performed by the machine, then the element of the ID can be immediately updated in the test code as well. And we are close to the end of the operations. In the maintenance, one other very important task is prioritization, because infinite testing is not possible, right? I cannot test everything, so I need a prioritization in my test cases. For example, I told at the beginning that I have a limited time. Maybe I have 1 hour of testing window, and I have to select some of the test cases to execute. So what would you pick to execute? Most probably you would pick the most prior ones, right? And what are the most prior test cases? The ones that are most likely to find some bugs, right? And how can we detect them, or how can we pick them? We can again construct a model according to the past data, because we have lots of data, right? If we track data, we have a huge amount of data. Because, for example, in our project right now, we have daily runs. In a day, we have, I think, 6 or 8 runs in a day for all the test cases. So after a day, I will have 8 different logs, and in which of the execution we found a bug, I know that information. So at the end, I can find which test cases are more likely to find some bugs. So it's a very good opinion to pick those test cases which are very likely to pick some bugs, because otherwise, if a test case is passing all the time, okay, we can still execute it, but to picking a more prior test case is a better opinion, I think. And finally, about the bugs, normally bugs are some vulnerabilities on the product, and we report them to the developers or to the owners of the product, right? So assigning those bugs to the correct people is very important, because when I am creating a bug on our issue tracking system, I'm assigning to another one in the team, another team member in the team, and if it is not the correct assignment, then it will result in a waste of time, because he will say that, okay, man, you reported to me, but I'm not the correct one. I'm not the one who is responsible from this feature. So what we will face is I will reassign it and I will wait for the response for the other guy from the team. So it is a waste of time. So the correct assignment is very important. So when, as a human being, when I'm creating or raising a bug, I'm not checking all the previous examples. For example, in our current project, we have almost 1,000 bugs in the system. So it is not possible to check all the previous 1,000 bugs, because to reach to the consistency, if I'm trying to act consistently with the other guys in the team, then I will act consistently with the past samples, right? But for me, it is not possible to check all of those samples. But for a machine, we can do that. The machine can investigate all the previous samples, and it will take the most consistent action item relevantly. And similarly, we are setting the severity levels of the bugs. And in this project, okay, at this point, let me go over the example. In our project, we have 6 different severity levels, okay, starting from 1 to 6. 1 is the highest severity level, and 6 is the lowest severity level. And in this project, severity levels 5 and 6 are not real bugs, but they're regarded as change requests. So let's think that we have 4 different severity levels, and in the current real-life project, we don't have any severity 1 level, because it is related to human life issues. For example, if you have a hardware in your system and if you have a current leakage, it can result in some dangerous life issues, right? So those would be severity 1 issues, but currently we don't have any severity 1 issues. So in our project, we have severity 2, 3, and 4, 3 different levels. And I will construct a model from these almost 1,000 samples. And when I have an upcoming sample, I will try to predict the severity of the level of the bug. Let's check how I do that. First of all, of course, as you know, I extract the features. And since we are dealing with text values or strings, because we are reporting bugs in our language, right? In English, Turkish, or whatever it is. So we are dealing with string values. So in order to teach to the machines, we have to convert them to some number vectors. So this is called, as you know, the feature extraction. So since we are dealing with string values, we embrace some NLP techniques, for example, TF, IDF, and some other approaches. And we extracted some features, and we feed these features to the model. And now I will share the results. By the way, I tried them with my teammates over different algorithms, and I will share the results from them. And this is the distribution of the samples. I mean, from class 2, we have almost 500 samples, and for class 3 and 4, less number of samples. And this is the results for this distribution. And the overall success rate is 73% accuracy rate. So, okay, this may be regarded as an acceptable success rate, but we thought that it can be still improved. So we started to think about the weaknesses on this algorithm. Instead of the algorithm, remember the number of class 2 samples were very higher than the other ones. So there was an unbalanced distribution over the data. So in order to reduce this bias, the next thing we did is try to combine 3 and 4. Now I will try to predict if a bug is 2 or not. I mean, if 2 or 3 and 4. Does this make sense? Yes, it does really make sense, because in our project, class 2 means the release blocker bugs, and other bugs is not release blocker bugs. So deciding if a bug is severity 2 or not is a very important decision. So due to this, or after this distribution, this is the confusion matrix that we get. and it is much more balanced compared to the previous one. And overall success ratio is 82%. And for most of the machine learning algorithms, it may seem still a low rate, because this is a difficult study. Because what I mean, there is not an absolute fact, or there is not an absolute true in the study. I mean, I created a bug in my system, and I evaluated that as severity 3. But is it absolutely correct? I don't know. And there is not an absolute correct decision, because maybe someone else can regard it as severity 2, or someone else can regard it as severity 4, not severity 2. So it is really a subjective study, and it is really difficult to work on this. But at least we can say that, or at least personally I can say that doing this with the help of machines is much more consistent. And of course, there are still some improvement points still as well. For example, we can adapt some pre-processing steps to improve the data, or we can enlarge the data set to teach the machines, and maybe a better success rate can be reached. And apart from classification, we can make some, or we can monitor some clusters on the bug. And what is the point with clustering? How can I get some advantage from the clustering? It is really important, because I can understand if some of the bugs heap together on some features. For example, here you can see some different clusters. And if I see some certain words on one of the clusters, for example, in first clusters, let's imagine that I see mostly asset words, okay? Then I can understand that most of the bugs are heaping together on the asset feature. Then I can go to the asset management guys and ask them, okay, guys, if are there any configuration problems on your service? Because I see lots of bugs heaped on your service. So monitoring some clusters of bugs can help us in some manners. And this is the visualization of this study. So it is not very straightforward to interpret this visualization, but at least we can see that they can be separated in groups with some slices on the 3D representation. And I'm running out of time. This is the summary of what we discussed in this session. The key point from this talk is I'm a software tester. So what is the relationship between me and machine learning? What can I do with machine learning in my activities? We tried to get some answers to this question. Actually, we can do lots of things with the help of machine learning in software testing area, starting from the first stage, starting from the definition of the test cases, until the maintenance of the test cases and maintenance of the bugs or issues, vulnerabilities, weaknesses that we found. So we have lots of things to do in different stages. So as a conclusion, we can really embrace the machines in our activities, and we can really collaborate together to improve our processes and improve our products. So this was the main idea of this talk, and I hope you all enjoyed and get some ideas from the talk. Thanks for listening.
Thank you, Mesut. It was an interesting talk. Made me think about quite some different things. If people who are watching, of course, have any questions, please don't hesitate to ask your question through the stream channel where you're watching on. If it's YouTube or Twitch or Twitter, there's different ways to send a question to Mesut right now. So we'll give them some time. In the meantime, I had a question. On one of your slides, you were showing or classifying the bugs that were coming in. And you could say, like, is it severity number 2 or severity number 3? Wouldn't it be, I'm just thinking out loud, wouldn't it be also a good idea, instead of classifying it with in specific groups, giving them a percentage of how severe they are?
I think I did not hear well
Okay,
the question.
Instead of doing a classification on them, like this bug we say it's a severity number 2, but the AI says it's severity number 3 based on NLP analytics. Now, instead of saying, for example, it's 2 or 3, we say it's a number between 0 and 100 and give it some kind of regression.
Okay. Yeah, that's an idea. Yeah. We can try that but the thing is, we in this study we don't have any continuous grade
No.
For the severity levels, and we have some district levels, 2, 3, 4, and something.
Yeah.
But still, we can do that. And for example, if we have 2 point something, then we can assign the closest number.
Mm-hmm.
Yeah, that's an idea. It can be tried. Yeah,
It's maybe a way of ordering also your bugs which are ranked higher, because you might have severity 1. Maybe you have 5 of them, so which one is more important?
It's a good idea. Yeah, because we can still try that, because it's not a study which is in a major situation. So we are still working on that with my mates. So yeah, maybe I will try that. Yeah.
Cool.
Thanks for
more of your results. Maybe we will see in the future.
Yeah, I hope so.
Well, we don't have any more questions at the moment. So everyone, thanks for watching this episode. Of course, we have another episode next week, same time, same place, and we will have Praveen Raghuvanshi. Sorry if I pronounce your name incorrectly, Praveen. And he will give us some introduction and using C# on Jupyter notebooks, which is quite new also. So for you software developers, how are you going to use machine learning with C# in a Jupyter notebook? Looking forward also to this episode. So Mesut, thank you very much for joining us today. I was happy to have you on board today.
Yeah, and thank you very much for having me. It was a pleasure for me. Thanks so much.
Thank you very much. So with this, we will close our episode. Thank you everyone for watching, and I hope to see you all next week.
Bye-bye.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Exit Sami in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Amy, Nederland test. I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，我是马内朗。
I'm Farkas from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California. Hi, Midi Eddie Daoud, Refactoring.
Hi, I'm Ana Filana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hi.